21. Alyssa and Gabriel play the following game. Alyssa rolls a die. If she rolls a 1, 2, or 3, Gabriel gives Alyssa $3. If Alyssa rolls a 4 or 5, Gabriel gives Alyssa $2. However, if Alyssa rolls a 6, she gives Gabriel $14. So determine Alyssa's expectation. So Alyssa could win. Well, wait, no. What could happen to Alyssa? So she rolls a die. If she rolls a 1, 2, or 3, Gabriel gives her $3. So she could come out $3 ahead if she spins a 1, 2, or 3. So if she rolls a 1, 2, or 3, the probability of that, there are 6 numbers you can possibly roll on a die. So 3 out of 6. So she'll get $3 about half of the time. And she could also roll a 4 or 5. And if she does that, Gabriel gives Alyssa $2. So she'll come out +2. And the probability of rolling a 4 or 5 is 2 out of 6. Last possibility, she could roll a 6, and then she would give Gabriel $14. So she would have to give him $14, so we're going to make that negative. And one number there, so 1 out of 6 chance that she'll have to give him $14. So always check to make sure we have all the possibilities. It looks like we do, because there's only 6 possibilities on a die, right? 1, 2, 3, 4, 5, 6. We've accounted for them all. 3 6 plus 2 6 plus 1 6 is 6 6. So it's looking good. We have all the possibilities accounted for. So we're just going to multiply x times p of x, and then for all of them, and then add them up like we've been doing. So let's see. So 3 times 3 6 is 9 6. 2 times 2 6 is 4 6. Negative 14, I won't forget the negative this time, is negative 14 6. Add those all up. 9 plus 4 is 13. Minus 14 is negative 1 6. So negative 1 6 is about negative point. It's 1 divided by 6. So if I do 1 divided by 6, I get 1 6 6 6 7. So it looks like she's going to lose about 17% every time she plays this game. So let's check that. 21. Yeah. So if she's going to lose, this is Alyssa's expected value. So if Alyssa's going to lose 17% every time she plays, if we did the same thing for Gabriel, it would make sense that he would win 17 cents every time he played. So that's Alyssa's expected value and Gabriel's expected value. Alright, so that's that one. We'll move on to 25. So 29. Assume that a person spins the pointer and is awarded the amount indicated by the pointer. Determine the person's expectation. So we set up our chart, x and p of x. So if he lands in the red, he wins $1. And if he lands in the yellow, he'll win $5. Looks like there's half the time he'll land in red, half the time he'll land in yellow. So just x times p of x. So 1 times a half is a half. 5 times a half is 5 halves. Add them up. 1 half plus 5 halves is 6 halves, which is 3. So our expected value is 3. That's that. Keep going. We do 33. Two envelopes contain a $500 check, and 3 envelopes contain a $1,000 check. Let's see. Read the instructions. A person randomly selects one of the 5 envelopes. Each envelope contains a check that the person gets to keep. Determine the person's expectation if the checks in the envelopes are as follows. So 2 envelopes contain a 500, 3 envelopes contain 1,000. Alright, so you have possibilities. So you could one possibility is to open an envelope with a $500 check in it. So you could come out $500 ahead, and 2 envelopes out of the 5 give you that possibility. Another possibility is you could win $1,000 and 3 of the 5 envelopes have $1,000 check in it. Now when you go to add these, 2/5 and 3/5, that adds to 5/5, so we've covered all our possibilities. So now we're just going to make our third column, x times p of x. So 500 times 2/5 is 1,000 over 5. Just multiplying the tops, 500 times 2. And 1,000 times 3/5 is 3,000 divided by 5. Again, just multiplying the tops. 1,000 over 5 plus 3,000 over 5 is 4,000 over 5. And if I do that, I'll get 800, I believe. So, looks like you're going to average about $800 expected value. Yep, they agree.